Okay, good morning everyone. We are going to go straight in today with a bit of a starter. So there you go. You can see it there. Pascal's triangle. Just to jog your memory, starts 1 1 1 1 2 1. You'll need to take it one further line than that. You'll want to pause the video in a moment. I'll go through it all. So hopefully you put your extra line on here of being 1 3 3 and 1, and when that's the power 3, this is the line that we want. So we're going to have x cubed plus 3 times x, drop one power from that and introduce the first power of h, and then it's 3 again, drop one power from the x's, add 1 to the h's, and then we just get the one lot of h cubed on the end, and that's the answer, and that's going to be important for what we do later on. Right, morning everyone. As you can see, dressed for work today, apart from the lack of a tie, but who needs those? Got my magical mathematical waistcoat ready to go. And today we are going to be finding the derivative, or differentiation from first principles as it's otherwise known. So let's get cracking. Right, so our example today, you may want to just jot this down. Prove from first principles that the derivative of x cubed is 3x squared. What's that asking about? Well, what that's saying is, if you have the curve y equals x cubed, the function that tells you how you can work out the gradient at any one point is 3x squared. You may still be wondering what I'm talking about. So if we have a little look on the calculator here, here's y equals x cubed as the curve. If you look at just think about the gradient of it. It's very steep and positive down here, isn't it? And it's gradually getting less steep, but it's still positive. Less steep, less steep. At the point when it goes through 0, it's totally flat, and so the gradient is 0. Then it's getting a little steeper, 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 but always positive. Now, if x equals 0, 3x squared will give us 0. At all other times, because x squared, when you square a number, you get a positive. We're going to get a positive value, and the bigger the positive or negative value is, the steeper it'll be at the same amount. And it happens to be just the right amount to get our gradient. That's the point of what we're doing. What we're going to do today is show how you do it from first principles, which is a question that comes up a little bit. If you don't like it that much, don't worry, because there's a nice quick way that we can get from x cubed to 3x squared that we will do in the future, which works for most questions. But it's always good to know where things come from anyway. So that's what we're doing today. So what we're going to do is we're going to say, right, thinking back to what we did yesterday when we found the gradient of a line and we moved it all down until we had a distance of 0 going on. We're going to go for a couple of points on the line x cubed. So the first point we're going to go for is just going to be x for my x coordinate. Now if my x coordinate is x, what would y be? It would be x cubed. And the second point, we're going to have, like we did yesterday, we're going to have the x coordinate as being x plus h. So we're just adding a little bit on to what our x value would be. Now if it was that much bigger, our x value cubed would be x plus h cubed. So I'm going to write x plus h cubed in there. Those are the 2 points. Now what we've got to do is find the gradient between them. So remember, gradient we get by taking our first x value from, not our first x value, is it? It's our first y value, because it's the vertical change over the horizontal change, and then we do the same with the x values. So we're going to do that with what we've got just here. So the gradient is going to be x plus h all cubed, take away the other y value which was x cubed, and on the bottom, much simpler, x plus h take x. Let's deal with that bit at the bottom first. That's just going to be h, isn't it? Now we need to expand x plus h cubed, which is why we did that earlier in the starter, so that I can then just write that out again. If you remember, we had x cubed plus 3x squared h plus 3x h squared plus h cubed, and then take x cubed on the end there. And what we can do with that is just cross those out, because that's going to cancel away from there, and then I can factorize the top, not fully factorizing it, just taking the h out, so that I can then cancel it with what we've got below. So that would leave me with 3x squared plus 3x h plus h squared. Then we can divide top and bottom by h, and we get 3x squared plus 3x h plus h squared, which isn't quite 3x squared yet, is it? But don't worry, because it's going to be, because at this moment we need to think about what we were doing yesterday when we were making the value of h a smaller and smaller amount as we got closer and closer and closer to what our curve was going to be. So then all we have to do is write that the limit that we want for h is going to be gradually getting closer to 0. So underneath lim, which is just short for limit, we put h with a little arrow towards 0, which means the limit is going towards 0. And we have 3xh will tend towards 0, because when you multiply 3x by 0 you get 0. And we'll also have h squared tends towards 0, which means we're just left with the 3x squared. So we call that the derivative becomes 3x squared. And that's it. That's done. Now all I want you to do today is have a go at doing that for the exam questions on exercise 12b. So that's exercise 12b, and that is questions 5, 6 and 7. If you get confused, and you may well do, please do email me and I'll get back to you and help you out on that. Okay, enjoy that folks. Goodbye.